everyone and welcome back! In the previous lesson we saw how to optimize the re-rendering of our UI to only re-render things if we have a different list of messages to display. Now we want to take this one step further and only calculate here a new message if the message is effectively new, if the message has been calculated before, meaning we receive here a reference to a message to which we already mapped into a message view model. We want to return the result of the last calculation. So in order to do that, we can also memoize this calculation here, which is the mapping between a message and a message view model. We can change a little bit the implementation of this function in order to extract here the participant name. So let's pass in as argument for this function the participant name, which will be a string. And we are going to use the participant name here. Next, we are going to define the participant name here as a local variable inside this mapping function. So the participant name is this variable. We have it here. We can now use the participant name to pass it to the map. And we want to add here, just to make it clear, that this is what is being returned from this mapping function. We could always extract this function into a separate function if needed. Right now, because it's only 2 lines, we can keep it like this, as it's still quite readable. So we take the participant name and we pass it to this mapping function. Now what we can do is we can memoize the result of this calculation. This means that instead of using this function to do the mapping, we are going to use a memoized version of it that will cache the output for each combination of inputs. So if we pass to that memoized function the same name and the same reference to the same message, we will get back the cached result. So how do we create a memoized version of this mapping function? We are going to use Lodash and we are going to use a utility called memoize. We're going to pass it in a function reference. In this case, we are going to pass it in the reference to our mapping function that we want to memoize. And then to that, we are going to pass in the participant name. But take a look, this would be creating a new version of this function each time. So the cache each time would be empty. So instead of doing this, we are going to create here a function that is a memoized version of the map message to message view model. Now, because the function is not used anywhere else, what we can do is we are going to make it a const and we are going to call memoize. We are going to pass it in then this function here. So first the arguments, then separated by a fat arrow, the body of the function. Then we simply close the parentheses here and we have here a memoized version of this function here. If you would ever need to use this somewhere else, we could always extract it into a separate function. Now, taking the result, which is the memoized version of the mapping function, we are going to pass it in here. So now that we have defined a selector using reselect and here a memoized mapping using the Lodash memoized utility, let's try this out on the screen. First, we want to fix here an issue here in this getter. So there's the possibility that we have not yet selected the current thread. So let's test for the existing of the current thread. If the current thread is there, we are going to return this. Otherwise, we are going to return the empty array. So we might think at this point that the use of memoize is completed and everything would work as expected. It turns out that it's not the case, because let's consider a bit how memoize works. Basically, it has an internal cache that maps in something to a result. The result is the message view model that we are going to return. But the question now is, what is the key of that cache? The key by default is the first argument of the memoized function, which is not what we want. We want some combination of the message ID and the participant name in case the participant name changes. So in cases when the first argument of the memoized function cannot provide a valid cache key, we need to provide here a second argument, which is a function. And this function will take the same arguments as the memoized function, and it will return something that will be used as the key of the cache. So we are going to use a combination of the message ID plus the participant name. So now that we have fixed this issue, let's switch back to the browser and see if everything is still working as expected. So as we can see, this part of selecting the current thread, this is already working. Now let's try to exchange here a couple of messages as usual. So as you can see, everything is still working as expected. But now, whenever we have the application without exchanging messages, like it's the case here, and we are receiving new messages each 3 seconds from the server, we are not repainting the application at each 3 seconds, because the state that is coming out of the store, meaning the list of messages here, for example, or the list of threads, is exactly the same each time, meaning we are producing a new snapshot of state, but it's pointing to the same threads, to the same messages, to the same participants. So any part of the application that is using on-push change detection, like for example the message list or the thread list, this does not get re-rendered each time. Now if we send here a message, we still have the whole list being re-rendered. That is because our message list component, let's switch to it, let's open it here. That is because our message list component here is receiving each time a new list. So if we produce a new message, we are going to trigger the creation of a new input list. So this will trigger the re-rendering of this template. Now, if we want to avoid this situation, what we can do is we can create a component here that renders only the message and pass in the message as an input. What would happen in that case is, because we are memoizing here the mapping between message and message view model using the --memoize utility function, because we are doing that, this means that if the message is exactly the same, we are going to receive the exact same message view model. So this means that this part here would not be re-rendered. So we are going to quickly implement this component here. This will be a component that renders a single message and really only exists for view optimization purposes and to enable on-push change detection to work effectively. We are going to implement this new component in the following lesson.